So now we are back to the Java world, and our next talk is 5 tips to make your Java apps more awesome. Non-functional requirements exemplified. And my pleasure to welcome my good friend and good speaker, chief engineer at Computers, Java champion Rustam Mehmandarov. Hi,
Hello,
Rustam.
everyone. Thank you.
Hi,
Thank you
hi.
for the introduction, Oleg. And it's really great pleasure to be
My
back
pleasure. My
again.
pleasure.
It's a great pleasure to be back again in Ukraine, even though again this time it's virtual. But I really hope that
Oh dear.
sometime soon we'll meet in person.
For sure. For sure.
Thank you very much for the
Time will come.
introduction as
Time
well.
will come.
Yes. All right. Let's just jump right into it, and then we can do. So what we can do is that I encourage you to ask questions, write comments, do anything that you would like to do that. And Oleg, you're more than welcome to either interrupt me or if you want to do it at the end of the talk, that's fine as well. Just let me know whenever you're okay with that, and then we can do this. Both things work with me for me. All right, let's get started. So I want to talk a little bit about things that we don't really talk sometimes too much about. We talk a lot about how containers work, how to build the most amazing containers, how to build the most amazing microservice architecture, and how to build this and that, and all these things. How to split up the monolith. We talked about a million times before. But what we don't really talk about is this, what I call the non-functional requirements, and what actually makes what makes the Java applications, different from the way we used to develop them back in the day. So when I started working, it's getting some time, getting longer and longer back in the past, but around 16, 17 years ago, when I started doing Java development for work. We would just develop an application, slap it onto a Tomcat or JBoss or something, and then you would have a Linux or Windows server running somewhere in a basement or a room next to you. You would just deploy to that, log in remote desktop to that thing, deploy on the Tomcat there, and just made it run. And that was it. Then you were done, and then you would just go on to a new version of it, and a new version of it, a new version of it. Later, we decided oh, the pipelines is really good, and automation is really good, and containers is really good idea, and all these things. But there are a few things that we kind of changed that we don't really talk about, and that's what we will see if we can talk a little bit about today. So I'm going to be using Java examples, and we're going to be using the Java, one of the Java frameworks, or Java EE, what used to be known as Java EE. It had different names: J2E, Java EE, Jakarta EE now it's called. But I will be using that as an example. But all of the things that I'll be saying and I'll be showing you, you can actually be implementing at any other even language platform, or if you want to do it with Java. Because I remember when I was in Kiev some time ago, a few years back, I would ask how many of you use Jakarta E and how many of you use microprofile and things like that, and then there would be not that many hands. And then when I ask Spring Boot, there will be like a huge majority of the room. So if you want to do Spring Boot, if Spring Boot is still popular, since we're doing it virtually, I can't ask this again. But I mean, if you're going to do that, you can still implement a lot of those things that I'll be talking about. But now I want to do more of Java EE, Jakarta EE native kind of approach, and I'll show you examples using that. So what is that thing, Java EE, Jakarta EE? Some of you probably know it, some of you don't, so I'll spend a little bit of time. So because a lot of languages out there that we have, that are, well, not Java, but the other ones, they usually have, well, quite often, not usually maybe, have this idea of batteries being included. So, if you need a HTTP library, yeah, it's included. If you need this, it's included. That is included. Java, it's a bit more stripped down, and all this is and cool things that we need and that make things better and nicer for as a developers, and has some simplifications that they bring to the table. Those things usually have been part of this thing that we see on the screen. It had changed names throughout times. It started with JP, J2EE, Java EE, Jakarta EE, and well, now we are at the version Jakarta EE 10, which has been released quite recently. And this is the a set of libraries that actually um, make your development easier. And also, when it comes to developing cloud native applications, that's what we'll be talking about. So, what you can see here in the screen, you can see that there is a different pieces that combined are Jakarta E10 platform. And there is a lot of things that are grayed out, and they are grayed out on a purpose because we're not going to be talking too much about. There are like libraries to send emails and to do messaging and servlets and security and faces and all these kind of things that we don't really need to look at right now, but they probably will be very useful if you're going to do those things. But what we'll be focusing on is actually the things that are called core profiles. So it's kind of the base, the foundation for a lot of things. So it's a lot of things that where you work with JSON, you do all this kind of JSON bindings and all this kind of stuff. There is a thing with annotations, interceptors, RESTful. Well, obviously, since we're creating microservices and cloud native applications, a lot of communication will be happening through some kind of REST-ish interface. So RESTful web services is an important part of JSON processing, since, well, for the same reason, and obviously dependency injection because it makes things easier. On top of that, what I'll be using some of the things that are not part of Jakarta EE core profile, but are built on top of that. So all of those things that you've seen in the previous slide are that little yellow box in the bottom there. You see it says Jakarta E10 core profile, and there are things on top of that, and they are also things that really help your application to get even more cloud native. So we have things like fault tolerance and metrics and all this health and all this kind of thing. So all of these things are there, and you can just simply use them. And again, if you're using some other kind of frameworks or ways of doing that, you should probably expect something very, very similar, because a lot of those things are about automation, clouds, and things like, I don't know, Kubernetes, health checks for Kubernetes and restarting containers and all this kind of stuff. So this is a little bit of background. So this is a little bit of the things that I'll be using. And now let's talk about those 5 things. Before we do that, it's an important thing to mention that all the things that I have shown you, all the boxes, all these little colorful boxes and their contents, is actually a very in reality it's specifications. So it's there is a document like this. So for example, this one is the specification for the whole core profile, and it's basically a bunch of things how it's supposed to behave, and it's up to someone to actually implement it. So when it comes, for example, to micro profile world, those specifications are being implemented by several different providers, including bigger and smaller ones like Red Hat, Microsoft, Red Hat, Oracle, what is there? IBM. There are a bunch of others that implement that, and they have to pass through some certain tests to claim compatibility. So it's a kind of important thing. So there are different implementations of things as well. All right, so let's talk about the first of the 5 things that we would like to have in our applications to make them more resilient, more cloud native. Cloud native is all about automation, all about putting things in container, putting things that are, you can observe and fix and everything with as little toil as possible, so as little manual work as possible. So one of those things is one of the important things is fault tolerance. So what happens when something fails? So this is basically you rely on something called endpoint X or functionality X, and that is failing. What do you do now? What happens? How do you handle it? And this is the way you do that, the way you handle it is a very important thing. You can obviously code it yourself. You can obviously create things yourself, but you don't really want to do that. That doesn't make sense, right? First of all, why, right? We talked a little bit about, things failing and what happens when it fails. But also, if it fails, what do you do? What do you actually decide to do? Do you just, crawl up in a corner into a fetus position and just cry, or you actually give a stack trace to your users, or you just do it gracefully and say, hey, something went wrong, we're sorry, we're working on it. Maybe you even don't want to do that. Maybe you just want to seamlessly switch to another endpoint that is less precise, maybe less good, maybe less uh, I don't know what, but it still works, and the users will maybe not notice. They will still have a little bit worse experience, but they will still have some kind of experience with your solution, with your website, with your software, whatever that is. But also another important thing is that there is a lot of, you look at postmortems, what they call, like, so the reviews of things failing out there in the world. You will see a lot of cases where this microservice architecture saying something fails within, something else keeps on retrying and knocking onto that endpoint that is failing, and then you end up saturating your network. So basically, in reality, somehow DDoSing yourself, and everything goes down instead of just one little piece going down and everything kind of keeping on working and just giving some little bit less or a little bit more deteriorated experience to users. It just, everything just crumbles to and grinds to a halt, and that kind of sucks, right? So that's a little bit about why. How do you do that? Well, what you can do in, so here I'm also going to be referring at the bottom there. There are links to the specs that I'll be talking about. So there is this specification from MicroProfile with annotations that you add to your code. But again, there will be something similar in other frameworks as well. So things that you can expect is something that where you can specify timeouts. So, how long are you supposed to wait on something? If something is not responding within whatever you have as your SLA, and if it fails, then you just might want to fail over to something else, or you just give an error but still respond within the time that you actually agreed on to your users to be responding within. There is a bunch of things like retries. So how many retries you want to do before doing something else. Fallback, which is a very important thing. If something fails, if something is not behaving the way it's supposed to, you just define a fallback function and do something else. So for example, let's say you have a weather service that is very precise and very nice, but not that stable. But then you want to, and that is, when it's not stable, you want to fall back to another weather service that is a little bit less precise and a little bit not that good, but it's more reliable. It's always there. You can just fail over to that, try to retrieve data and give it, and maybe show a message saying, look, this is approximate weather, but we'll more precise weather will be coming back in a second. We're working on it, or something like that, right? There are things like also circuit breakers, because when things go in a loop, you want to be able to break this circuit and say, hey, okay, we've tried this thing so many times, now this is not working out. And there are things that's also like bulkhead and asynchronous, which we don't really need to talk about, but you can also read about that. It's actually pretty cool stuff. So if you're interested, you should have a look at the specification. There is a link all the way at the bottom there, but you can also search for MicroProfile fault tolerance spec. So the way you do that, I'll be showing you some code in a little bit, but I can show you some like static code for now. But I have actually, I can show you here. Right here is the actual code that I will be showing you in a little bit. So for now, it's a little bit of a screenshots kind of code just to give you an idea, and at the end I'll show you the whole thing. And the repository, by the way, with all the code and everything is public, and they will be also linked at the end of the presentation, so you can play around and see how things work there as well. So what do we do here? So you can see that we're defining a REST client. So I'm annotating my code with a REST client. So I'm basically generating some code that is able to talk to another REST interface, and the other REST interface is can be found at localhost 8080. And then I also tell it that there are things like there will be a path. There is a path called message, and if that message is being endpoint that's being called under API, so basically /API/message, if you go there, it should call a function called, oops, I should not click on my slides. That's a bad habit. But so if that endpoint is being called, you just go to get that data method, and it will just retrieve you or give you back the data that you want. If it fails, so here I also specify what's going to be producing, so it produces JSON and stuff like that. The most important and interesting part here is the fallback. So now I say, hey, if that thing is failing, and we'll see how we'll introduce the failing part as well. I mean, how we fake it to fail at will. But if it fails, what do you do? Well, if it fails, you just go to this get that other data method. Very, very carefully chosen names for methods, obviously. But that is the one is specified down here. That is actually a backup message endpoint. Speaking of failing, so I needed to introduce a failing function in my code, and I needed to do it kind of randomly. So as you can see in this code, I mean, if you're really quick at reading code, I don't really expect you to read the whole thing, but the whole idea is happening here is that when you call that API message endpoint, you actually just return a string message hello there. But it happens only sometimes. And the way it happens is you roll basically a dice, and so you'll get a number between 1 and 6, and if it's divisible by 2, if it's then everything is okay, and if not, then it will just fail. So you can see here it's like roll divisible by 2, success is true, and if success, you just respond with OK message, so HTTP 200 with the message and stuff. And if not, then you just give it some kind of error saying some weird error, and actually just return 500, HTTP 500. For the backup code is simple. You just return a message, and you actually say a backup hello here, because then we'll see when it actually fails over to another message or not. Another thing I want to talk about is, so now we talked about like what happens if something fails. Now I want to talk about what happens if so how do you know if something is about to fail? So how do you actually make sure that you can check the temperature of your application and see if it's running too hot, running too low on something, or things like that? And this is a way of looking inside your application, and especially when you're running on I don't know, in a container, inside a serverless environment, or inside a Kubernetes, something. It's really hard to actually like open the box and look into it. And here we, yeah, okay, I have a really bad pun that I decided to add there. I'm kind of very not sorry, but sorry about it. It says "What's up, app?" Yeah, kind of not very proud of it, but I still keep it. So I don't know. You go figure. But anyway, so the point is, you need to know how your application is doing. That's the important thing. So is your container up and running? Can you actually ping your container and say, hey, how are you doing? When you know that your container is up and running, you need to check if the application inside the container is actually up and running, because it might have just failed at a startup and just crashed. So you need to do that. And you need to do those things for several reasons. So one of the reasons is the scaling. And by scaling, I mean, you can implement some things that we'll talk about in a second, where you create rules of when your application should be scaling up, should be scaling down. Maybe you want to create a minimum number of instances it will be running, or maybe you want to actually create an application that will scale down to absolutely 0. In any case, you just want to make sure that you have some kind of metrics to look for. And when you spin up new containers, or when you kill the containers that are not in use, you actually need the information from health to actually know if that container is ready to receive requests, or if that container is actually working on processing some kind of request and stuff like that. So how do you do that? Well, there are a few tags and a few ways of returning that information. So readiness, that's the kind of the ultimate uh, test of, are you actually ready to serve requests? Are you alive? Are you alive will come later, but this one is like, are you ready to serve any requests? Can I route some traffic to you? But then you have startup, just to make sure that everything is started up and everything is up and running. And then you have a liveness request. Those are just basically probes, like a pings, that check, are you alive? Are you alive? Are you alive? So if you stop answering to liveness requests, then you might want to actually, scrap the container, kill it, and then start another one for um, spin up a new one, a fresh one that actually works. Okay, so we talked a little bit about what happens if it fails, how to look inside your application if it's ready or not. But there is also more. There is also a way of measuring uh, your actual application stuff. So inside your application. So until now, we talked if containers up and running, if application is up and running, if the application is getting able to get hold of its own database or something like that, right? Now we talk about metrics, and the metrics part is actually quite more fun, because now you are actually able to define custom application metrics for your stuff, and expose that to the platform. So now let's say you have a really heavy application that uses a lot of I don't know, memory or CPU or something like that, and you want that application to if you hit some kind of threshold of that usage, you want to scale up several new containers to satisfy the request, because you know that if it goes above that point, everything slows down, everything goes slow, everything becomes unbearable for users. And to do that, you need that custom metrics, because it's not based on certain things that you get out of the box, but maybe it will be on, I don't know, disk utilization, things like, things that are a little bit out of the usual, out of the normal kind of metrics stuff that you usually get included. Typically, you will get like CPU usage, memory usage, things like that. Yeah, so we talked quite a lot about why already. So you want to measure those custom parameters, and you want to make them very specific to your application only. How do you do that? You can actually create those again, annotations, and that's the kind of cool thing about Jakarta or Java or whatever you know this thing under. Well, now you should be knowing it as Jakarta, and a lot of things are usually done there with annotations. So you just create an annotation. In this case, you can just create a counter saying, "Hey, I want to create it. I want to create a counting metrics, just telling me how many times that method is being called." So count me A will be counted, and it will also add tags to the metrics. And count me B will also be tagged, and both of them will be counted under the same variable called count me. And it's also an absolute value, and so on and so on. But for example, might want to add different tags. So in this case, I actually added the same tag, same name, same everything. So they actually will be counted as one thing. But I can also separate those. You'll see that in a little bit. Another cool thing is that, and by the way, that's also a microprofile specification. So this one is called, well, health, surprise, surprise. And it is made available to you out of the box. If you just add it, it will be available at /metrics. So if you go to /metrics, it will give you a lot of information. And that information is going to be not very readable for you as a human being, but it will be very useful for automated solutions. Like, let me show you what I mean by that. So if we go here, I have a solution running, and I'll explain the solution and everything in a second, but for now, just bear with me, and I just want you to show this wall of text that is being generated by metrics. And most of those things, actually, in this case, everything is generated automatically. So this is what you get automatically out of the box. And actually, if we let's go to 1982, and here you'll see that we have created some custom stuff as well. So you see this tags. I created a tag called purpose, and I give it a value of failover and purpose of being a total. So totally, it's been called 5 times, and nothing have failed so far. And that's like if we go to this one, refresh, go back, refresh this page. Now it's on 6. So this is how you create counters. I'll show you code and everything in a little bit, but the idea is to show you that there is a lot of text that's being generated. You can also generate some help messages and explanations and stuff, but in general, it's most of it is actually auto-generated, and then you can add your stuff. So in this case, those two. All right. Back to the slides. So yeah, everything is being exposed as metrics, then you can consume it automatically by things like I don't know, Prometheus or Grafana or something to visualize and show it and in a way you want. One more thing that I want to talk about that is not a microprofile thing, that's not a Jakarta E thing, that's not any of those things at all, but it's a very, very useful thing for the world of cloud applications, generally applications in general, but it's something that we have not been doing for some time. I mean, traditionally in old days, good old days, as I call them, like I told you, like when we were starting working with things, a lot of those things that we call feature toggling now would have been a config file. And it would be in some kind of dot properties, application properties, something file. There would be like a bunch of them everywhere. There will be like different levels, application level, environment level, global level, something, and they will overload each other. And then you would be able to specify things, especially if you have a solution that you provide to different clients. You want to define like names of the company or headers or whatever you want to put there. Those things work really nicely. But if you want to toggle some features, that is not really a good solution, because usually you will need to restart your application. Usually it will take some time. Usually it will mean some kind of downtime. Back in the days when you would just have one Tomcat instance, I mean, you will just get away with a little bit of downtime, right? You will just reboot it, go into that machine, restart, and you're good. Nowadays, when you have like 100 million different containers everywhere running, it becomes like a cat herding. It's a little bit difficult. I mean, of course, you do it with deployment pipelines and deploy new version and all these kind of things, but it's not something you want to do for smaller things. And why do you want to do feature toggling at all, you might ask? It is basically a way of making your features available. And why do you want to control that, you might ask again? And well, because some features you want to make available only for a specific country, or only for a specific geographic region, or only for a specific group of users. Only admin users will see that button. All the other ones don't have this, or only admin, whatever will users will see that endpoint and the others will not. This kind of thing. So sometimes you want to create a subset of functions available to a subset of your users. That's one thing. The other thing is that you want to create gradual releases. So you want to make some features available to just a handful of users. So you deploy the same application, but you just say, hey, I want to turn on this feature for like 10% of my users and see how it behaves. And if it behaves nicely, I can increase it to 20, and then I can increase it to 100, and then I'm happy. And also, Also, very important part of that is what you do when your features are partially delivered or partially developed. So, for example, when I was working on a large project, we would be developing things, and sometimes the front end people would be faster and they would create all this, and back end people were not ready. Or back end would develop things and front end people would not be ready. Or sometimes everybody would do everything in time, but then the customer would come back to us and say, hey, you know what, we're not ready to release this feature for reasons. Can you hold it back? What do you do now? Do you actually just remove the code? Do you like create a new branch? Do you roll back the Git log? What happens if you manage to commit some other stuff that has to be part of that, but not this part? So it's a lot of issues, right? But if you have a feature toggling, you can just implement that and say, okay, cool, we'll remove this feature, we'll not make it available, we'll not make it callable, and until somebody actually flips a little, literally a switch, and it just makes it available again. You can do all that with your own developed stuff. You can, of course, create a bunch of if-else sentences if you really want to hurt yourself, because, I mean, you will be able to do it once, maybe twice. It will get boring very fast, and it will be very, very hard to remove and to control and all that. One important thing that I want to talk about here is that when you create those features, you want so we talked a lot about when you should use that and when you should add that, but at least as important part of this thing is when you should remove them, because you should not have a feature toggle staying there forever, because if the longer they stay, the more kind of people lose the knowledge of why they're there, and the more people will start to believe that they're the kind of the sacred animals that you should never touch again, because if you touch this, bad things will happen. If you remove that feature, for which makes no sense at all right now, half of your application will start failing and stuff, and then you will be stuck there with a horrible amounts of features that nobody uses but nobody dares to touch. So it's very, very important to have a strategy to remove them, and also to make sure that all those feature toggles that are not used, are not being utilized over a specific kind of period of time, then those feature toggles should be removed from the application. So expiry date, like all good things, you have expiry date for your features. It's very, very super duper important. I can't really underline how important that is. Really, please do not leave them unattended. But then there is a question. So how do you do that? Do you just write your own code? I was doing this talk in at a conference, I think it was in Krakow in Poland, and there was somebody asking like, hey, but why do we need to do all this? It sounds a bit more complicated. For my simple solution, I can just write an if else. And yeah, of course you can. I mean, technically you can implement an AI with if else, and if you put enough of them, it will look kind of magic. But do you really want to do that? Do you really want to implement all that all over the time, right? And or maintain that zoo of features? So putting in a config file, well, we talked about that. It's kind of okay, but not really working for quick changes. And well, the other thing is using a tool. So here I'm using a tool. I'm going to be showing you a tool that is an open source tool. They do have some kind of paid solution and stuff, but I'm not associated with them in any way. I'm not really. The only reason I'm mentioning and advocating for them is because they actually have an open source free solution that you're more than welcome to just clone from GitHub and use. Or also another a little bit less important but still kind of cool feature is that it's also it was made in Norway, where I live and work right now, and well, I've been living here for a long time, and it's it's just a little bit of a fun fact that it was also made here. The way it looks, it's from both sides. So on an upper corner, you see how you do it with code. So there's the solution is called Unleash. So there was a link here in the back, on the bottom, sorry. And here is how you actually how it actually looks. So user interface is at the bottom and the code is up in the top. So you create an unleash object, which is basically points at the unleash server with username and tokens and stuff. And then you just say unleash is enabled, and then you provide the name of the feature. And if it is enabled and if it's specified in there, it will return, yeah, it's good. And then you can actually do a do whatever you want to do if that feature is enabled. So in this case, we're using the very important thing, very important skill that we have as developers. It's converting bugs to, well, as you can see from the code, to features. So it's not a bug, it's a feature. It's a very, it's almost as old saying as it works on my machine, I guess. But here, if we want to introduce chaos into a system, we have a toggle called chaos, and the bug suddenly becomes a feature. So I mean, very simple example, very hopefully not an example that you will use in production, but at least it shows you, it gives you an idea of how it works. Okay, one more thing, and then we'll go into the world of code, and that is how do you do all these things with environments, configurations, infrastructure. It's a big bucket of things that I wanted to put everything that did not fit into all the other four categories, because we talked about um, all these things like fault tolerance, health and metrics and feature toggling and all this, but none of this will actually be very nice and smooth as it can if your environment, if your configuration, if your infrastructure is not really set up properly. So first of all, there is a very important thing that we should probably always start and probably always say to ourselves when you wake up, you go to the bathroom, look at yourself in the mirror, and then you should say that. You probably should print it or over the mirror or something. And that is the one and only thing that you probably should say, and that is stop doing ClickOps when you set up environments. When you do things in a cloud, do not just go into a console and start clicking around and then uploading jars and it's like, hey, my application is working now. It's really cool. I did the same thing they did in a tutorial to getting started for that cloud. Now I followed the whole thing and now it works. Amazing. Now I'm ready to go to production. Do not do that, please. Because when you do ClickOps, and ClickOps by that, it means just doing it manually with clicks and stuff through some kind of web or whatever interface it is. It is that it's impossible to document. It's impossible to actually version. It's impossible to know if it has been done or not, or how it's been done. If you do instead some kind of infrastructure as code, or you code it somehow, you can actually commit that into your infrastructure repository, and then you can actually make sure that everything is reproducible, and this things like that. And like the lowest level of that is, for example, creating Docker Compose files. Then you can create which ports things are available and when do they start, what networks they run on, things. I mean, you'll see it all in my repository where I created the Docker Compose files to start all the demos. Actually, technically I have to start two different Docker Compose instances, but they both go on the same network. They both do that. They have like tests that they inside the Docker Compose that fail if something is not running and if the environment is not set up properly. And this is the lowest level. The higher level would be creating things much more advanced than that. And like I said, it's reproducible. It's documented because you can actually document and point and say, hey, this is actually, it works the way it's supposed to be. Obviously, it's automated as well. And if it is automated, then you don't have to do this boring task over and over again. And sometimes, because it's so boring, make a mistake, because some of us do mistakes when we do things manually from time to time, and it kind of sucks. But the only downside that I can't just sell it to you as a green grass and fantastic happy day sunny scenario, but the only thing is the only downside is it needs to be maintained. You really need to actually maintain it. If the script, if the code is not working, you really need to go into that code and fix it, make it run again, make it work, and then commit that code. So next person or next time you have to do it, you don't have to scratch your head and try to remember what was that thing that you had to edit after the startup or something. And what usually also happens that you have a script, you run it, and then after you run it, something is not really working just a little bit, and then you should go into console and do a little bit of click ops. Still not good enough. Don't do that. Do not go like give in for temptation. Um, so how do you do that? So infrastructure as code. There are a bunch of ways of doing that. Terraform or OpenTofu. What's it called? What's it been forked into? There is also Pulumi. There is also things like for configuration. There is a spec called microprofile config, which is really, really nice way of creating special configurations for your applications. But also, when it comes to infrastructure, think about which level do you want to run things on, what do you want to do, and that is like, are you doing infrastructure as a service, or you do platform as a service, or you're doing serverless, or you want to go good old way of creating virtual machines and putting things onto them for some reason, because because you actually have a need for that. But you really need to think about it. Do not go all the way into Kubernetes world and just go, hey, we're going to go like Kubernetes and 3 different nodes and huge amount of machines and hardware and stuff. You probably don't need Kubernetes, at least not right away, unless you're having a huge application with huge load of things. Maybe you just need a little bit of maybe you just need a tiny little VM, or maybe you need a serverless offering of some kind. And by serverless, I actually mean you don't really even need to go onto the cloud. And all of those things that I'm mentioning, you don't really need to be running on the cloud to utilize or to get hold of those and to actually get benefits of those. And if you really want to go on the cloud, but on your own on-prem, there is also solutions for that. So there are things like ways of installing on-prem clouds in-house, and there are ways of creating serverless even deployments and stuff like that there as well. To mention one, it would be Knative. So that will actually let you do serverless applications on top of Kubernetes and on top of a service mesh, and so it will do all this serverless management of your containers as well. And that can be on-prem. It doesn't have to be in the cloud, not in a public cloud. You can also create your own private cloud stuff. All right, so demo time. I want to show you a little bit of so here is the repository. I will show you the link later, but I mean, if you look a bit closer, you'll also see the link obviously in the address bar, but that's fine. And also the name is here on my GitHub repository. To give an idea what's going on, it's I created 2 services, a service A and service B. Service A is a kind of a front-end API for API front-end for my application, and that API is using some kind of backend service to retrieve some information. The endpoints for a front-end are very easy. There is a hi and there is a feature. And also on the back end, I am also using, so hi message is a hi endpoint, sorry, creates, uses 2 API calls that are being API message and API backup message. And so that hi on service A does not know anything. It will call service B, message, and it will try to retrieve that message and show it to you. And if that fails, it will go to a backup message. And there is also a feature endpoint that is basically just doing the feature. And of course, as a nerd as I am, I ended up drawing the whole thing in ASCII doc. So in ASCII. So the whole architecture of this thing is actually a pure ASCII markdown thing. So just because, I mean, just because you just do things like that, right? Yes, and it's pretty well documented everywhere. So all throughout this README, so you can look at that. So let's go to the code, and here I have a few handy things. So one side here, I actually have I actually have a list of endpoints. So there is actually a really nice feature in IntelliJ now that actually lets you list all the endpoints that are available and where they're available and all that. So this is really cool. So you've seen all this now in a drawing. So you have a demo service and demo backend service. So this is kind of the front on the API, and that one is the backend for that front end. When I say front end, don't think about web. So we're not talking web, we're talking API front end. And on this side, it is the structure of the whole thing. So as you can see, there are two different folders. So there is a service one and backend service one. Here is the README that I have been showing you already, and there is a really weird bug in IntelliJ that sometimes I need to restart the README file that is not showing anything, and then you need to close the window, open it again, and it just works. So now we're there. So here is the thing. So front-end service, high, and so on. So the 5 things that I've been talking about, they're also documented here. They are documented in the wiki file. So the same feature, close, open again. Now it's visible. I don't know why. So fault tolerance, this is, for example, an example to look at, and where you want to actually have a look at is the front end and the back end where things are implemented. So in the front end, this is the piece of code that you've seen already. We're creating a REST client, and we are we're able to use the message and backup message, and we actually define those 2 paths that we will be talking to. Let's see. Folks on the other end, on the organizers end, please let me know if I'm running out of time or how much time I have, because I can pretty much now, I am just going to show you stuff until you stop me, because I don't have any more slides. I just have some code to show to people. All right. I guess you will let me know somehow. Okay, let's look at the code. So this is the first part, and the second part is this, and this is actually a more fun part. I'll minimize the endpoints so you can actually see the fun things. So this is actually the backend message and backup message of the code. And here, as you can see, we're looking for this chaos variable. So if you look at the browser, we go to 1980, which is, according to our documentation here, 9081 is front end of that API, and 82 is the back end, right? So we go to 9081 slash hi, and then it will just keep us giving hello there. So I keep on refreshing, as you can see probably up there in the tab. I'm refreshing, and it just gives us the same thing. That is because it never fails, and that is because we don't have that actual feature there yet. So if we create a new feature called chaos, and we go, yeah, that's fine. Create a feature toggle, and then yes, go away. So now we have a feature. So we just go into chaos feature, and we can make it available on development or production environment. So if I make it available on development environment here, it is. And by the way, Unleash is actually running on another set of containers here. So if we look at my containers here, and you ignore the first 2 containers, that's for another different project, but this is the actual thing happening here. So I have a Docker Compose for Unleash that has 2 containers that doing the Unleash stuff, and I have my 5 features talk demo that has 2 another containers that is backend and the client, web service client and web service backend containers. So now that I have enabled that thing, all I need to do is just to zoom in. and keep on refreshing. And already on the first refresh, it failed, and it actually returned me a backup. And now it's like failing. Sometimes you can see it's like refresh, 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 refresh. Oh, it failed. Refresh, failed again. Refresh, 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 failed. And now, actually, if we can go into metrics just to show you that it works, I'm going to show you metrics. Metrics for the backend, so 82. Now we can see that those two things that we've been running here, they've been updated. So we have called a hello message 49 times. So 49 times the front end called the backend service for hello, and 8 of them failed. So I know that 8 of them was a failover, and in general, in total, it was 49 of them. Cool. By the way, how do we do that? Well, we can actually have a look at that as well. We go back to Wiki and we go into the metrics, and let's go into that. So close that. Let me see. No, I don't need this. Cancel. I don't need this for now. Okay, go back. So here is the metrics. So this is the way I did was what I had to do was just that. That line 50, counted, messaging service, absolute true, purpose, total. And that's all. And then the same thing was for the failover. That was here, my backup service. And it's the same thing. So line 85 is the same thing, purpose failover. And that's all. I just needed to add those two annotations, and automatically it just generated and all this. All right, let's go to the next thing. What is this? Health package. So we talked a little bit about health, and there are ways of specifying health checks, and the simplest health check is like this. You basically do a override health check response, and you override a call function, and you just do something and return something. So this is the most simplest way. It will always return it's up and running, and it will just say started application started. But you want to do some more advanced stuff, and you want, for example, do liveness response codes. And for liveness, you can actually do, for example, things like you can call your backend, get server response code from the backend, see if the response code is 200, and then you return yes, it's running. If not, if it's down, it actually says, well, critical service, blah blah blah, something stopped working. And that is really, really nice way of doing things. And you can actually, see. If we go back to README and go to the health, so we can just go here. So the back end is very simple. There is not that much stuff implemented, but front end is a little bit more elaborate on the implementation of different health applications. So here you can actually see liveness probes, 2 of them, readiness probe, and also a startup probe. So typically a startup probe would be something like, okay, this is fun. Response time is fun. So what you can do, for example, for response time, and that's the liveness probe, the one that you see, one of those you see here, the first one. And you can also see that the actual documentation of it this is where it comes from the code. So it just says self-health check, response time. Here I actually created a thing that checks if it takes too long time. So if things takes more than 3 seconds to get a response, it will give you a failing test. And the way you do that is that you actually implement it in your code, where you just create. If you go back to the documentation, I'll show you there. So we have this thing called delay. We have a variable called delay, and if I activate that variable, it will sometimes take, actually always will take 5 seconds to reply. So, okay, let's go. Default, new feature toggle, delay, create a feature toggle, enable it. So what happens now is that within a few seconds, already, as you can see, so you can see up here on the tab, is that it takes quite some time for it to answer. So it actually takes exactly 5 seconds every time to answer, because I just put in a sleep there. So 1, 2, 3, 4, 5. Yeah. And what happens now is that when we go back to health, so everything was actually peachy right now, right? Everything was happy and everything was okay. And if I refresh now, you see that it's actually hanging because it's trying to ping the backend service, and it takes actually 5 seconds for it to respond. And within 3 seconds, that thing will actually fail and say, hey, you know what? Liveness, critical service high is too slow. And it will already give you an error. So status is already down and not up like with the other ones. And again, if I just feature toggle that thing to, can I, okay, if I turn it off, then we can go back and refresh. And so it takes a little bit of time. It takes usually around 4 or 5 seconds for the features to propagate. So it seems like it's not propagated just yet, and it already did propagate. So now we're back to up and running. Everything is good. All right. Okay, let's see. What else? What else can I show you? So if you want to see all these things, and if you want to study them all on your own time, you should go into the repository and actually look for this wiki markdown file. So that's where all this feature toggling and metrics and all these things are. And I also added links to the environments and all this. Unless there are any questions, I will like to show you, yes, you've seen this already. I'd like to show you this one last slide with all the links. So you're more than welcome to ping me on social media. So what you see there are Mehmandarov, that's my Twitter handle. But if you want to find me on other social media, just go into the link below, rustam.no, and you will find them all different ones, Blue Sky and whatnot. And down there is also the link to the repository with all the code and everything. And by the way, all the drawings, I ended up drawing them myself. So if you think they're kind of weird, they probably are. Thank you all for joining me, and you're more than welcome to ask questions now or ask questions on social platforms and things like Twitter or Mastodon or Blue Sky or whatever you prefer to use. Back to you, Oleg.
Yeah, thank you, Ruslan. Thank you. That was a like great presentation as always. I mean, there are no questions in chat, but there is one guy, David, who actually like shared the link to your repository, which is helpful. That was probably your
That's really nice. Thank you.
co co-presenter, or just the guy who was like working together with you in background in chat. But yeah, I mean, as you
Amazing.
said, guys,
Thanks for
please to reach out to Rustam and Twitter or any other like social channels, and kind of ask your questions if you have any. But this is something
mm,
that is quite relevant topic with what we are doing today, especially with regard to observability nowadays. This is
yeah,
like kind of the must thing that you have in each application, in each and every application.
yeah. And it's also things
Cool.
that we kind of tend to forget sometimes. So that's another fun
Yeah.
thing. Yeah.
Yeah.
So don't forget those
Yeah.
things.
Yeah. No,
Thank
absolutely.
you very much.
Thank you, Sam,
Thank you
for
very much for
joining.
having me,
Was
and it's been a pleasure, great pleasure to be back again.
likewise. Likewise.